Hello, Brian Miller-Hicks here. I'm going to talk about water and construction. Water, of course, is a crucial, vital issue when you're talking about earthwork management, construction management, the effects of water on foundations and excavations. So I'm not necessarily talking about surface water flow like streams, rivers, rainwater. That can be provided for by adequate surface drainage. What I want to talk about is how it affects our subsurface for whatever project we're building. So, controlling factors for groundwater flow. As I've explained in a previous PowerPoint presentation about groundwater, I'm not going to get into all that detail in this one. But groundwater, of course, is held within and among pores between grains of sediment or minerals in rocks or within fractures and voids in whatever subsurface material we may have. So it's not, as some members of the public think, it's not a flowing river under the ground, although that does occur in karst and cavern type subsurface topography, but that's not what we're talking about necessarily. So what controls groundwater flow is, of course, gravity, inflow from the rain, melting snow, infiltration from streams, the addition of water from irrigation and artificial sources. Water is held by, as I've said, faults, fractures, bedding planes, pores. It's also dependent on the permeability. The permeability of a subsurface rock or soil depends not only on the porosity or percentage of voids in a rock or soil mass, but it also depends on the interconnectedness of these pores. That gives it its permeability. So when we encounter water, it can come up just about anywhere, even in a dry site. You may be surprised when you're digging for your investigation and it's a dry site and you find groundwater at 3 feet below ground surface. If you dig a little deeper, maybe it's dry, maybe it's not. So just to say that groundwater is, tracing the path of groundwater is very difficult and can be unexpected and pop up in unexpected, unpredictable places. Okay, so here's an excavation at a construction site. I don't know where this is, I don't know what this is for, but it's obviously a problem. You're digging an excavation and groundwater infiltrates through pores in the soil that are interconnected and flood the bottom of the excavation. Well, these are not good working conditions, are they? Something has to be done. How do we handle this? Well, we can de-water an excavation. So here we have the ground surface, a soil layer A, and within soil layer B, that's where we find the groundwater. This is the water table surface or piezometric surface. We've dug this excavation, we've installed a shoring wall, which is porous because we want the water to be able to drain through and not build up behind. That can cause an immense amount of pressure against the wall and the wall may fail. So we want some drainage. We want it to drain through the wall into the excavation, and then once the groundwater is within the excavation, if we were to allow it to continue groundwater level, it may reach an elevation roughly through here. So in order to operate at the bottom of the excavation and to deepen the excavation, we need to de-water it, which means placing well casings at various points within the excavation. We can then get into these well casings and pump the water out and away from the excavation This results in what we call a cone of depression at these well points, and that has the effect of effectively dewatering the excavations so we can work in the bottom and build our structures. Now, this type of situation may require continuous dewatering. Let's say this is a basement that wants to be excavated a little bit deeper. So you have to put pumps in the bottom of the basement excavation once it's completed. So it's a continuous problem, a continuous battle between draining the water that's coming into the excavation and keeping everything dry. Okay, that's one way to approach the problem. This is an example of a very, very, very dangerous situation. You can see this is, granted this is a fuzzy photo, but you can see this is already the side walls of the excavation are starting to slump. This excavation has penetrated wet, saturated materials, not necessarily pure groundwater situation with a water table filling up the trench, but these materials are saturated and wet. This guy shouldn't be here. Yeah, he's wearing a hard hat. He doesn't have a safety vest on. There is no shoring supporting the walls of this excavation. Shoring is a series of supports that are put into the trench and ram up against the trench walls via hydraulic pressure. They can be made of aluminum or steel or even wood if it's done right. So, unsafe situation. This person, hopefully this didn't happen, but these walls could collapse on him and he could be buried in a matter of seconds. The backhoe operator shouldn't be allowing this person in this unstable, unsafe trench. That's where saturated materials and groundwater can be hazardous. Here's another hazardous situation. A tunnel is being drilled, opened up. It's penetrating the subsurface materials below a groundwater table. All this pressure has been released by via this excavation. Now water is pouring into this tunnel through various fractures and joints and other means of the water to flow through. This, of course, is hazardous. You don't want any workers in here. This tunnel is going to have to be pumped out before work can resume. So, water is dangerous if it's not controlled, and if people are placed in a hazardous situation, they can be injured, they can even die. So what do? We require dewatering. We lower the water levels. Of course, that increases effective stress on excavation walls, which can lead to collapse or caving. Rising water, of course, can affect operations. I've been in a few high-rise downtown excavations in San Diego where groundwater had to be continuously pumped out to provide safe conditions for workers, including myself, at the bottom of these excavations. It can be a scary thing. I really did not like working in excavations with water issues like these. Rising waters can dissolve cementing agent in soils and rock that loosens everything up and causes failure. Okay, so that's a short trip through the issues of groundwater during construction, during excavations, and thank you for your time.